Hi students, welcome back to the second lesson on method of joints. I'm looking at that same frame there, and because we looked at this joint here, we were solved for this member and that member. Okay, so those two unknown. We can't go to that joint because we got three unknowns. Can we go to this joint? Yes, we know this one. We don't know those two. So now we can go to joint F. Okay, that's why we're going to joint F. So now that's known. We're going to solve for FE and FG, knowing that horizontal applied load and the force in AF already. Right, let's do it. Alright, what's the rules? Any force that's not vertical or horizontal, we resolve into components. Okay, we know that AF is in compression. Now, very careful. Compression, that means it's pushing toward the joint. Okay, I'm going to resolve it into its components. Looks like this. Okay, and we know the force here. Okay, we know the angle. The angle is 60 degrees. Okay, and now people, just a word of advice. A lot of students, when they come to a joint like this, because they've solved it early on, they come here, they just leave it completely out, and they say, no, I'm going to look at just FE and FG. That's wrong. Okay? Remember this force here, this force, bits of it are running into AF and to FG. Nothing is got. This load here, nothing is, FE carries none of that. Okay? Because there's right angles to it. But members AF and FG are both sharing that load there in some way. So that means you've got to account for it again. Okay? Even though we know it, I resolve it into its components and solve accordingly. Right, so that's 60 degrees. So that there will be AF cos 60. AF cos 60. I'm going to write it over here. Oops. And that's going to be AF sin 60. I'm going to write it like this. Oops, that's not going to be good. AF sin 60. Right, FE. I'm going to assume it to be in compression. Remember, E in the frame sitting somewhere over there. It's 5 meters away. I'm not concerned what's happening with what's happening at the right end of E. And FG, I'm going to assume it to be in compression too. Okay. I'm not, G is far below here. It's off my screen. Yeah, by my feet. It's 5 meters away. I'm not concerned with the lower end of G. I'm just concerned with the upper end of AF, the upper end of FG, and the left end of FE. Okay, one error only, not two. If you put in two, you're going to confuse yourself. Right. I've got to resolve forces in FG as well. So let's just do something here. Right, that's 60 degrees there. So that's going to be FG cos 60. FG, sorry, my apologies. Let me just undo that. And that's going to be FG sin 60. FG sin 60. Right. Do I resolve FE? No, I don't. It's horizontal. So what do we do next? We sum verticals and sum horizontals. Right. So let me just get something nice and blue here for us. Right. So let's see. I'm going to say the sum of the forces in the vertical plane is equal to 0. How many vertical forces do I have acting at joint F? It's plus this one, plus that one, minus that one. Doesn't matter the order, just take them all. I'm going to start there. So I'm going to say it is AF sin 60 minus 12 plus Fg sine 60 is equal to 0. Why is it equal to 0? Because the sum of the forces in the vertical plane is equal to 0 and F, joint F, is in equilibrium. Right, let's see then. Do we know what AF is? Yes, we know AF. AF is, what's AF? Did we solve AF on the previous occasion? Let me just see. Just give me a second. Yeah. Right, AF was 26.56, so we know AF, so therefore we can determine FG, so therefore, right, let's do a quick calculation there, so therefore FG, right, let's see, it's 26.56 times right, so FG is equal to I get minus 12.70 kilonewtons. Notice the minus, okay. Right, what does the question want us to determine? The question wants us to determine the size of the force. It's 12.70, don't worry about the minus. What does the minus sign tell us? This minus sign tells us there that our assumption that Fg is in compression is not correct. It's actually in tension, so it's doing that over there. Okay, so therefore Fg is not compression, Fg is in tension. Be careful. Okay, the size of the force in Fg is 12.70 kilonewtons, and Fg is actually a tension member and not a compression member as we thought in the beginning because of the minus sign. Right, are we done? No, we need to solve Fe. So I'm going to solve horizontals. So I'm going to say the sum of the forces in the horizontal is equal to 0. Right, how many horizontals do we have? That's plus, that's minus, that's minus. Okay, so it's plus AF cos 60 minus FE. Right, people, watch this. This here, this member, it's not actually a compression member, it's a tension member. So I'm going to resolve that again into its proper components. So this is going to be looking like this. Oh, sorry. And that there will be, what's the angle over there? The angle is 60. So that's going to be Fg cos 60. And that there, let me just do it over here, is going to be Fg sin 60. Okay. Now people notice, both horizontal components has the same name, but opposite direction. Both vertical components have the same name, but opposite direction. Okay. Right. Down to I'm resolving forces. So it's AF cos 60 minus FE plus FG cos 60. Okay. We're using the force as it's supposed to be sitting. FG cos 60 is equal to 0. Right. Can I solve for Can I solve for FE? Yes. I know AF from a previous calculation, which is 26.56, and FG is the one we just found it over there. So therefore, FE is equal to right, and what did you get? You should have gotten 19.63. So it's 19.63 kilonewtons. Alright, what does the question want us to determine? The size of the force and the nature of the force. So the size of the force is 19.60 kilonewtons, and the answer is plus. What does it mean? It means that our assumption that FE is in compression is in fact correct. Okay. So if I go back to my, I don't know if I can do this. If I go back to my original page there, if I can do this, that is, no, I can't do that. Okay. Silly me, I tried, but it doesn't work. Okay. So therefore, I have now solved for, so FE is in compression and FG is in tension. So now I've solved 1, 2, 3, 4 at the bottom. I've solved 4 members. Okay. Right. So let's just have a quick look there. If I just throw out, we've solved members FE, we've solved members FA, AG, and members FG. Okay. So can I go to, let me rather just throw the sketch in. Just give me a second here. Right, people, I've got in a frame there. So let's just quickly just talk to it. Right, we've solved member AF. AF is in compression. We've solved FE. FE is in compression. Lovely. We solved FG. FG is in tension, so it's doing that. Okay. And we also solved AG, which was in tension, like so. Right, what are the rules? What joint can we go to next? We can only go to a joint where there's not more than 2 unknowns. Okay, that joint's done, that joint's done, that joint done. Can I go to that joint? 1, 2, 3. No, I can't. Can I go to this joint? 1, 2. Yes, I can. Why? Because when I come to this joint, AG and FG is solved. Okay, let me put the numbers in quickly here. So that's E, D, that's P, and that's C. Okay, so to go to my next joint, I can't go there because that member, and that member, there's 2, 3, it's more than 2, can't go there. But if I go to G, that member's done, GE I can solve, GB solve. So the rules are, I go to a joint where there's not more than 2 unknowns. So that's the next joint I'm gonna go to. Okay, so what I'll do is I'll give you a kickstart when I get to the. I'll do the next lesson on that joint there, solve the joint and some forces, and see if we take it from there. Okay, see you in the next lesson.